All right, hi everybody. Welcome back to this section 4.1 video. So in this last video, as we've worked our way up to a homogeneous and non-homogeneous solutions, we're just going to finish this up with verifying a solution to a non-homogeneous differential equation is in fact a general solution. So let's just remind ourselves of what a general solution to a non-homogeneous differential equation consists of. So this component that's like C1, C2, we have e to the 2x, e to the 5x. That's our complementary solution, and we typically denote it as y sub c, our complementary solution. And our particular solution is that 6e to the x. That's our particular solution to this non-homogeneous differential equation. So just a reminder, like what makes this a non-homogeneous differential equation again? Well, it's at 24e to the x. It's a free-floating x term. It's not attached to a y component, so this makes it non-homogeneous. Okay, and so if I wanted to, uh, the way I get the solution to the homogeneous portion, say, this is now homogeneous. If I just drop that 24e to the x. So now I have a homogeneous differential equation, and it's given to us that a solution is C1 e to the 2x plus C2 e to the 5x. So just a little refresher on homogeneous, what makes it homogeneous, how the complementary solution relates to that, and what makes a differential equation non-homogeneous. Okay, but the question is asking us to verify, right? So we just want to verify that this entire solution is a general solution to this non-homogeneous. So it's a second order, so we're going to need about two derivatives. So let's go ahead and try that out. So here we have y equals c1 e to the 2x plus c2 e to the 5x plus 6 e to the x. Second order differential equation, so I got to take two derivatives. So this would be 2 c1 e to the 2x plus 5 c2 e to the 5x plus just 6 e to the x. And then we want to take a second derivative. So this would be 4 c1 e to the 2x plus 25 c2 e to the 5x plus again 6 e to the x. Okay, great. So we have our derivatives, and we're just going to take these and plug into the differential equation and verify that it is a solution. So let's go ahead and plug these functions in, or excuse me, the derivatives in. So this would be, you know, plugging them into here. This would be 4c1 e to the 2x plus 25 c2 e to the 5x plus 6 e to the x minus 7 times 2c1 e to the 2x plus 5c2 e to the 5x plus 6 e to the x. And then plus 10y. So this would be plus 10 times c1 e to the 2x plus c2 e to the 5x plus 6 e to the x. And that it all equals 24 e to the x. Okay, so quite a long one, but I think things are going to simplify out quite nicely. Let's go ahead and uh, distribute in this -7, distribute in this 10. and take away some of these parentheses. So what we get is 4c1 e to the 2x plus 25c2 e to the 5x plus 6 e to the x minus 7, excuse me, minus 14 c1 e to the 2x minus 35 c2 e to the 5x minus 42 e to the x. Now moving on to the third set, this would be plus 10 c1 e to the 2x plus 10 c2 e to the 5x plus 60 e to the x, and it all has to equal 24 e to the x. So let's take a look. That 4c1 e to the 2x cancels out right about here. We have a 4, we have a positive 4, positive 10, and a negative 14. So those c1 e to the x terms cancel out. And so I have a 25 c2 e to the 5x. And so those c2's e to the 5x will cancel out 25, negative 35, and a positive 10. Okay. And so I have a 60 e to the x, a negative 42 e to the x, and a positive 6 e to the x. Well, that reduces down to 24 e to the x. So 24 e to the x equals 24 e to the x. So it is a solution. Okay. So therefore, the solution y equals c1 e to the 2x plus c2 e to the 5x plus 6 e to the x is a solution to the non non-homogeneous differential equation y double prime minus 7y prime plus 10y equals 24 e to the x. Okay, so that's our first taste of working with a non-homogeneous general solution. So we built all the way up to these general solutions. And so now after this point, we're gonna be diving into how to actually get these general solutions with various different methods. So this section 4.1, was all about preliminary theory and our building blocks. And now we're going to take it forward and solve these homogeneous and non-homogeneous differential equations. But thank you for watching, um, and see you in the next video. Okay, goodbye.